chemical bonding, intermolecular forces, and metallic bond. Okay, in intermolecular forces, at the end of this lesson, students should be able to describe what is intermolecular forces exist, which is van der Waals forces. In the van der Waals forces, we have dipole-dipole interaction and London forces or dispersion forces. And also another one intermolecular forces is hydrogen bond. Intermolecular forces are attractive forces between molecules. Generally, intermolecular forces are much weaker than covalent bond. The strength of intermolecular forces will determine the physical properties of the substance. So physical properties such as boiling point, melting point, and state of the molecule. Okay, we have types of intermolecular forces. So two types of intermolecular forces that we are going to learn is van der Waals forces and hydrogen bond. And inside the van der Waals forces, we separate them into two other separation. The first one is dipole-dipole interaction or permanent dipole. And the other one, London forces, or we call it as dispersion forces. In dipole-dipole interaction, dipole-dipole interaction exists between polar molecules. If you remember, before this, we learned about polar molecule and non-polar molecule. How to determine? According to the molecular geometry. So, recap back to the previous lesson to determine whether the molecule is polar or non-polar. So the forces exist because of the positive end of the dipole on one molecule attracted to the negative end on another molecule. So positive end attracted to negative end on different molecule. Okay, so these forces also called as permanent dipole. And the forces effective only when the molecules are close together. Okay, so if molecules stay far away, there are no intermolecular forces. But if they stay close together, then intermolecular forces will exist. So this is orientation of polar molecule in a solid. So one part will hold partial positive and another part will hold partial negative. So the partial negative and partial positive on another atom or on another molecule will be attracted. The partial negative will be attracted to partial positive on the neighboring molecule. So that is what you call as dipole-dipole interaction or dipole-dipole forces. Okay, so all of these molecules have interaction between each other. Okay, London or dispersion forces, also called as temporary attractive forces, the weakest intermolecular forces that exist in all atoms and molecules. All molecules will have these London forces or dispersion forces. Non-polar molecule can only have these intermolecular forces. Okay, so if you meet with non-polar molecule, automatically it will be under London forces. What happened in the London forces or dispersion forces? A molecule or a atom can have electron around the atoms. So this electron will be moving. Okay, they will move around the nucleus of atoms. The constant movement of electron cause temporary dipole moment. Okay, so when electron from this side, so around here, move to one side. So it will cause temporary dipole exists. Okay, so on the side the electron deplete, it will be delta plus, and on the side where electron is rich, so it will be delta minus. So this is temporary dipole. When the electron move again, the dipole will change again. Okay, because of the unsymmetrical distribution of electron. Okay, so when one molecule or one atom has uneven distribution of electron, it will induce the neighboring atom or neighboring molecule to behave like it as well. So since this side has more electron, the electron from this side will move to the opposite direction. Okay, so as we know, electron hate another electron, so they will repel each other. So if electron decide, the electron on the neighboring molecule or neighboring atom will move to the opposite side. So this will cause induced dipole on the neighboring molecule. Okay, so starting with one molecule having temporary dipole, it will induce another molecule to have induced dipole. So because of the induced dipole, the negative side will be attracted to the positive side of the molecule neighboring. Okay, so in the second atom, distorted by the appearance of dipole in the first atom. Okay, so lead to electrostatic attraction between the two atoms or the two molecules. So these forces, so the forces of attraction between the temporary and induced is known as London forces or dispersion forces. And this interaction only exists or only significant when the molecule or atom close together. Okay, so if they stay far away, this interaction will not exist. Okay, so how to identify whether the molecule has dipole-dipole interaction or London forces? First, the keyword is polarity. Okay, polarity. If a molecule is polar, so for example HBr, so we know that H will hold delta plus, Br will hold delta minus, and this bond is polar bond. So only two atoms, so this bond will decide whether this molecule is polar or non-polar. So since this is polar bond, so the resulting is polar molecule. So when polar molecule, remember, London forces will exist in all molecule and atom. So this is a must. Added value, when you have polar molecule, automatically you have dipole-dipole interaction or dipole-dipole forces as well. Okay, so you have two types of intermolecular forces in one molecule. Okay, so SO2, same. SO2 is molecule. S bonded to O, and it in the V shape. So V shape, and this shape is not symmetry. So when it's not symmetry, mu is not equal to 0. So dipole moment cannot cancel each other. So the resulting SO2 is a polar molecule. So in polar molecule, same like HBr, a mass, London forces. So this is a mass, and added with dipole-dipole forces because of the polar molecule. Okay, so CH4. In CH4, okay, CH4 has tetrahedral shape. Tetrahedral shape. So tetrahedral is symmetric shape. So symmetrical shape where mu equal to 0. The moment can cancel each other. So it is non-polar molecule. when nonpolar molecule can have only London forces.